great test today.
Now remember, when you are dividing fractions, you can change division to multiplication of the reciprocal. So we would change this division of 4 to the multiplication of its reciprocal, which would be 1/4. And then we'll get 5 over 32. And same thing with the last one, we would change this division of 1/2 to be multiplication of the reciprocal. You only take the reciprocal of the second fraction, not the first one. And then again, if you want, you could cross reduce this. 2/4 is really 1/2, and then we would get 3/2, or 1.5. All right, so we can use the properties that we used yesterday when simplifying radical expressions when you multiply and divide them. So multiplying and dividing fractions, just like we've seen in the bell ringer or the warm-up here, it's easy. You just multiply across the top, you multiply across the bottom, and you simplify. What's going to get more challenging is on Thursday this week whenever we change this to a plus or a minus sign. Why? What do you have to have if you're adding and subtracting fractions? Abby? A common denominator. So if you changed this to be 1/2 plus 4/6, you would then have to make the denominators common, which will make these harder because you're going to have squared and linear factors. Okay, but multiplying and dividing, you're literally just going to multiply basically the tops and the bottoms. Remember that when you are dividing, you'll do exactly what we did right here. We will change division to multiplication of the reciprocal. And then you'll do the same thing that you would do with multiplying. Now, the easiest thing to do for these problems is actually to factor everything. And instead of multiplying and distributing everything, it will be easier because you'll be able to cross-reduce things. So you're actually going to factor this, and we're going to factor this. Not going to factor the x minus 4 because it's already factored. You may want to throw parentheses around it. Now, this first one that we're going to factor is a guess and check. Why? The a value is 2. So you can't just say what multiplies to 3 and adds to 7. It doesn't work like that when we have that 2 out front. So this one you have to literally trial and error what numbers will go where when you're unfoiling. So the first term times the first term has to be 2x squared. So that's 2x and x. The last two terms here have to multiply to a positive 3. So it's 3 and 1. But you have to figure out which one goes where. And we want them to FOIL back to get us 7, which means I want the 3 to go at the end of this. So that whenever I FOIL, I'm going to get 6x plus 1x, which is 7x. So just your little guess and check there. Now the next one, what does x squared minus 16 factor into? Ashley? Good, that's our difference of squares. Where we have one positive and one negative. That way when you FOIL it, you will get 0x. And then in the denominator, this is an easy factoring one. Numbers that multiply to 15 and add to 8 are 5 and 3. Positive 5, positive 3. Now, since this is multiplication, you basically could just take and make this one big fraction bar because you would multiply the tops together and you'd multiply the bottoms together. And then you can cross-reduce stuff. So anything you have in common, we can divide out. One pair of our x minus 4s, our x plus 3, and x plus 3. And that's all that I can simplify. You can leave your final answer in factored form, so you don't have to re-FOIL it. And on the answer key, you might not see parentheses around the denominator, but I kind of suggest it so that you don't start canceling out things you're not allowed to. Now, when you're doing your restrictions, remember the restrictions are that the denominators cannot be 0. So this one was x minus 4, so one of our restrictions would be x cannot equal a positive 4. And this one, the easiest thing to look at was our factored form, so x also cannot equal negative 5 and negative 3. Basically just taking the opposite or setting those equal to 0. Okay, the next two very similar, and then we'll switch to dividing. So we're going to factor anything that's a quadratic. Oh, really quickly, make sure you realize you cannot do this. That is 100% wrong. You cannot just cross off your a squareds. Okay. These are binomials, so you may want to put parentheses around them to remind yourself you can only cross off a binomial if you have a matching binomial. So we actually are going to factor this one, and this one. So this will become a plus 2a minus 2. In the denominator, this is another difference of squares. So this will be a plus 1a minus 1. What can I factor out of this one? Caleb? An a. So don't forget about your GCF. You can take a times the quantity a plus 2. And then we can divide on anything that's a common binomial. So our a plus 2 and plus 2. And our a plus 1 and plus 1. So in the numerator, I'm left with a minus 2. In the denominator, I'm left with a times the quantity a minus 1. Now the restrictions, remember, your restrictions are anything that ever showed up in a denominator ever. When we see dividing, it will actually include the original denominator and the new denominator when you flip it. So even though we cross these out, they still are restrictions. So a cannot equal positive or negative 1, positive 1. Don't forget about this one. A lot of you forget about this. If it's just the letter a cannot equal 0. And then also negative 2. So it should have 4 restrictions on that problem. See if you guys can try number 10 on your own, and then we'll take a look at 11, where we switch to division. We only have to do one step before, and then it will become the same as the last 3 questions. So anytime you see division, you just have to remember to change this to multiplication of the reciprocal. And it's the reciprocal of the second fraction, what you're dividing by. And then these ones are actually already factored for us, so isn't that just pretty? But don't start crossing stuff off because, again, you have to flip it first. So the reciprocal is just to flip the numerator and the denominator. Everything over here will stay as is. So the first fraction stays. The second fraction gets flipped. So we'll have x minus 2, 7y minus 5, and 5x minus 4. So we should be able to see that we can cancel out one thing, and that is our x minus 2. There's actually something else that we can do to be able to cancel out another pair. So do you see how this is x minus 4 and see how this is 4 minus x? Those are not the same thing, so you can't just cross them out. Okay? If you think about plugging a number in, like 2. 4 minus 2 is 2. 2 minus 4 will be negative 2. Okay, so it's not the same thing. You can't just switch around subtractions. However, if you notice that you have something really similar, but they're switched around, what you can do is you actually can factor out a negative 1. So if we factor out a negative 1, this will become negative 1 times the quantity negative 4 plus x. And then you can switch around, now it's addition. Negative 4 plus x is the same thing as x minus 4. So this would be negative 1 times x minus 4. Do you have to show this work? No. After this, seeing this example, anytime you want to switch these, if you factor out a negative 1, they will change symbols. So now we can divide out the x minus 4 with the x minus 4, but you need to have that negative 1 in your numerator. So let's get rid of that because I replaced it with that. So now I have negative 1 times 7y minus 5 all over 5 times 3x plus 2. And I don't know in the answer key if they actually distribute the negative 1 back or if they leave it. I really don't care. So if you get to the answer key and like they've simplified differently, as long as you get this or that answer, I don't care as long as it's been simplified. Now the restrictions. You have to look at a denominator that ever was a denominator. Okay, so you have to look back at the original problem, which were these ones, those ones, and then actually since you flipped this, you also have to look at this one. So any denominators that ever possibly occurred, those are going to be restrictions. So this one we should have negative 2/3. Oops. Can't be 2. This one also would be a repeat 2. And this one is our y variable, so I have to also add in y cannot equal 5/7. Adding 5 dividing by 7. And we also, when we flipped this, made this in the denominator, so the other one would be x cannot be 4. So we should have 4 restrictions. So just make sure you investigate the original denominators and once you flipped it, that new denominator. Okay, let's do one more and then I'll have you guys try the last two on your own. So these are all division on the back. So again, when you see division, just remember that you have to flip this and find your reciprocal. And if you want, you can factor as you go too, so that you don't have to do so many lines of work. I'm going to flip these around so that the a plus 1 is now in the denominator. Now the 3a minus 12, can I factor that in any way? Sam? Good, I can take out a GCF at least. And get a minus 4. And to save yourself time on the homework problems, you don't have to write the original question. You can go straight to the factoring, just to save yourself from writing it out a million times. And then these will factor. So we'll have a and a. This is a negative 15, so it's going to be one positive and one negative. So it's 5 and 3, and it's probably going to be a positive 5 and a negative 3, so that it adds to a positive 2. So plus 5 minus 3. And this is a difference of squares. A plus 4 and a minus 4. And then we go to town just crossing off anything we can. And that wasn't a lot of stuff. Oh well. Oh yeah. It could have happened that nothing cancels, just so you know. Rarely, really rarely, but yesterday in the notes there was one was on there. And then our restrictions. Again, make sure you check the original and the new denominator once you flipped them. So we should have a cannot equal positive or negative 4. This would also be 4. So I'm not going to write that again. And then I'd also have negative 1. All right, why don't you guys see if you can try 13 and also the closure.